Hi, so I'm going to be going through question 3 of the Maths Teams Olympiad. This question was fairly straightforward, I think. It required some A-level knowledge, but first of all I'm going to go over something which isn't in A-level, but it's an extension of A-level. So in round 1 I mentioned something about Vieta's formula, and Vieta's formulas, that's meant to be, formulas are to do with the sums of the roots. So if you have a polynomial in this form, which is just a normal polynomial, where n is an integer, so this is a degree n polynomial, it will have n roots, so some repeated, some not. But if you have this polynomial, if you want to find the sum of the roots, like so, this is equivalent to minus a minus 1 over am for any polynomial. To prove this is quite hard, you can use induction, or there's other ways to derive it, but I'm just going to be showing it to you. And so if you want to find the sum of the pairs of the roots, so there'll be R1 with R2 and R1 with R3, so the sums of the products of the pairs of the roots, and there's a lot of terms in here, and then all the way to Rn minus 1 Rn. This is equivalent to an minus 2 over an. So we can use these two generalized forms to help us with this problem. We would already know from A-level, you don't need to use these Vieta's formulas, but it may be useful in other problems to know them. So we've got our quartic here. It has 4 roots, so we can set the roots to be alpha, beta, gamma, and delta. So we know from Vieta's formulas the sums of the roots, alpha, beta, gamma plus delta, is equal to a, because you take this coefficient here and minus that coefficient, which is minus a, over 1, which is the coefficient of x to the 4. Well, that's just a. So we know the sums of the roots add up to a. And we're looking for the sums of the squares of the roots. So it might be useful to square this expression here. This gives alpha squared plus beta squared plus gamma squared, and so on. I'm not going to write all the pairs of the roots, but you know when you do the grid or whatever, it includes every pair twice. So you can say this is equal to a squared. So you take this expression and square it. This is what we're looking for. This is the aim. So we can rewrite this a bit more. Let's just write in here. This is nicer color. This is our aim to get here. And this is equal to a squared minus this 2 times nice. And we can say this is a squared minus 2 times, well, this thing here, this is the sums of the pairs of the roots. So we know from Vieta, it's equivalent to an minus 2 over an, which is the coefficient of a divided by 1. Well, that's just going to be a. So this is equal to a. Therefore, this right-hand side is equal to a squared minus 2a. So we've got the sums of the squares of the roots in terms of the coefficients now. And well, from this we can say this is a function. So f of a is a function, and you can have a squared minus 2a. Well, this is actually equal to a minus 1 squared minus 1, where you can see the minimum value of this expression is when a equals 1. So the minimum value is f of 1, which equals minus 1. So therefore, the minimum value of the squares of the roots is going to be minus 1, and that's your answer.